ones are here, 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 and here. So there's 5 points there. Which colored rectangles are the left-hand rectangles? Which ones are the right-hand rectangles? Yeah.
The gray ones.
Gray ones are which one?
The left one.
The left-hand, exactly right, because they're on the left-hand side of the top of each rectangle. Yeah. And then the red ones would be the right-hand rectangles. So it'd always be left or right. And generally speaking, one will be over and one will be under. Okay, so what does this represent right here? What is, if you add up all these rectangles together, what does that big one represent? The area of this one represents what?
The average. No.
It's not the average. What is it? It's the what?
The difference.
The difference between the
Upper and lower value.
Yes, exactly. That the area of that red rectangle represents the distance between the upper and lower. So our quest is to be able to answer questions like this, Noah, where if I gave you some function like here, and I said, okay, you're going from A to B, our quest is to find what is the exact area underneath that curve. Right now we have a way of estimating it by chopping it up into what shapes? Rectangles. As long as that red rectangle exists, there's always going to be a difference between the upper and the lower bound. So if we want to make our guess more accurate, what do we want that red rectangle to do? Shrink, exactly. And we want it to eventually shrink all the way towards 0. And once we get it closer and closer and closer and infinitely close to 0, we'll have the actual value underneath the curve. What was our mechanism for making that rectangle smaller? How did we make that rectangle smaller? What did we? More points. We took more sample points. So did we change the height of the rectangle? No. What did we change? The time. Like the time. Well, it's not always going to be time, but we called it time before. We're going to change the width of the rectangle. The width of the rectangle. So what you can see here is the difference between the lower and upper estimates. This was just a made-up function here. The upper estimate was 48. The lower was 20. And what was the width between each piece? 1. So what was that difference? What was that difference? Well, it's 20. 48 minus 20 times delta t. And in this case, that would be, what was delta t? What's delta t up there? Do you see it? It's 1. Yeah, I'm just making sure you can see it. Equals 28. So in this case, it's 28. If we do twice as many readings, it would be 14. If we do twice as many, you get 7. And then you get 3.5. So you can bring these estimates closer and closer together by taking more and more evenly spaced estimates. They don't have to be evenly spaced, but what did we realize yesterday when we did all the math and what you did last night? Makes it a lot easier, right? Because you can like factor out the half or factor out the quarter or factor out the eighth and just add a bunch of things together. If they weren't the same, can you factor out? No, the whole idea is you need a common term to be able to factor out. Okay, so let's take a look at this here. So what did we say? Right now, what's the difference between the upper and lower bound? 28, right? What happens if we took twice as many readings? What would that number become? It wouldn't be 28 anymore. It would be what? 14. So it would go from 28. If we took twice as many, it would become 14. If we doubled that, what would it become? 7, right? If we doubled that, it would become 3.5. Okay, so look at number 2 here. It says, how frequently must the velocity be recorded in order for the lower and upper estimates to be within 5 feet of each other? See if you can work on that by yourself for a little bit, and then we'll come together and talk about it. N in this one equals 4. So when n equals 4, you have an error of 28. You want 28 to go down, you want n to go up. It has to be greater than. You want to say, you think 7? What do you think, Noah?
22.
So Noah thinks it's 22. How'd you get 22?
Because we have 4 and you have 28, so if you had 8, you'd have 14. If you have 16, you'd have 7.
Exactly. So you'd use a little logic. Did you write an equation of any kind to solve? So let's build an equation. So what was does the 48 change? No. Does the 20 change? What do you divide it by to get how did we get, let's go back up here for example. How did we get 28? What was that? It was 28 times 1, right? Correct? Right? And where did that 1 come from? The delta t. Change in time, right? It was the change in time, right? So you want 28. And where did that 28 come from? Let's deconstruct it. What was that? So you want 48 minus 20 over delta t or multiplied by delta t? Multiplied by delta t to be what? You want that to be within 5. So you want it to be equal to 5 or less than 5 or greater than 5? Less than 5, right? You'd be within 5. So you want that to be true, right? Is everybody with me so far? Okay. So what do we now know? So what is delta t? So we say delta t, therefore, has to be less than what? 5 over what? 5 over what? 5 over? One person said it. Let's see if we can get agreement. 5 over 28. So you know what? They have to take, delta t has to be taken every 5 over 28, right? Does everybody understand what's going on here? What was delta t before? On the first example up there.
1.
The first example was 1. So it was 1 because what's the width of each of these? This is telling us if we want the error, overall error to be less than 5, we have to take it every 5 over 28 of a second. That's roughly what? How many seconds is that? That's roughly what? Point what? It's a little bit less than 1/4. A little bit less than 1/4. So I could ask you how many times, how frequently. So that is how frequently. The answer to the question is how frequently is what is delta t? How many times is it taken though? Meaning how many readings are you going to take? So it goes from 0 seconds to 4 seconds, and you're doing it every 5 over 28 times. So how many times is that? How many times is that? How do you figure that out? How do you figure out how many times it's taken? Do you understand what I'm asking everybody? So if I wanted to know how many times, so the frequency is a delta t, everybody. The frequency is a delta t. If I ask you how many times, it's going to be 4 divided by what? You said it, Noah. 5 over 28. What's that going to be? 4 times 28 over what? 5? Is that correct?
Yeah.
So what's that equal? That's 80 plus 32.
22.4.
It's 112 over what? 5, like that? So is it 22 point what?
4.
22.4. So if you wanted it to be exactly 5, you'd have to take 22.4 readings, but could you take a 0.4 reading? You can't take a 0.4 reading. So if you need it to be less than 5, do you want to go up or down from this number? You want to go up. So I could ask this question in 2 ways. So no, I could say, what is the time intervals to be exactly 5? You'd say, well, 5 over 28. But if I asked you, how many readings would you need to be within 5? What's the smallest number you can give me? 23. Because if you took 22, what would the answer be? You would get something outside of 5. Outside of 5. So let's generalize this a little bit here. So that function, I'm just taking out the values. This f of b, what was that before? That was what, 40 something? What was it, 40?
48.
It was 48. And what was f of a? 20. And what was delta t before? 1. This is now just generalized to any function from a. This value right here is x equals a, and this value right here is x equals b. All we're doing is generalizing it. So what could that function be, f of b? Any function. We're just generalizing it. All we're doing is generalizing it. How are we feeling so far about what 4-hour interval? What would be your guess? So based on these numbers, what would you guess? Yeah, Arvid. 107. Seems like a nice safe thing to do. Average the two. Nice, okay. What is the maximum possible error in your guess? In other words, what is the maximum possible difference between your guess and the true value? So what's the maximum possible error if you guess, if those numbers are correct and that's your guess? What would your max error be?
7 liters.
7 liters? Is it liters, right?
Yeah.
These are all liters, I think?
Yep.
Right? Okay. So liters, and liters. Nice. Okay. Suppose additional readings are obtained and compiled in the table below. Nice. So if you were to do this out, what's the quickest way to do the lower and upper estimates? What are the two, what line should I write out? Like what am I going to enter into my calculator to do the lower estimate on this one? Can someone tell me? What should I do for this one right here? Look at the table. What do I type in? Yeah, Noah.
Type in
What's the width?
Not the first one, all the rest, and just add them together.
Not the first. We want the lower and upper, right? So yeah, but what's the interval this time? So you'd have 1/2 times what?
Everything.
35 all the way up to what? 22, and then you'd have 1/2 times 33 all the way up to what? 21. Now it gets pretty tedious pretty quickly, right? like this isn't that bad typing in all those numbers, but what happens if I doubled the density or tripled the density? What's going to happen? It's going to get really tedious, right? It's going to get super tedious. Let's do a couple more layers of tedium. Let's just do a couple more levels. Do those out on your calculator, Randall. Do those two right there. Do those two. What's the width of it?
25.
What?
25 or 1/2.
1/2, right? And we know what the area is. What's the difference between 110 and 103?
7.
7, right? So what's the height of this thing going to be?
7.
Nope.
No.
The width is 1/2. So what's the height have to be?
3.5.
14. Other way, right? What's 14 times 1/2? 7, right? Let's go back up here. What did we have here? We had the area of our error box we know was, what's the difference between those two? 14, right? What's the width? 1. What's the height?
14.
So did the height stay the same?
Yeah.
What did the height stay? It stayed at what? How do we know the height stays at 14? Tell me where that 14 comes from on that table. Where's the height come from?
Comes from
Difference of what two numbers?
the upper and the lower.
Yeah. No, not the upper and the lower estimates. The 14 is not the difference between the lower. What?
The width and the error.
Look at the table. Look at the rate, everybody. Tell me where 14 comes from.
35 and 10 subtracted.
35 minus what?
21.
Minus 21. It's f of b minus f of a. So that number right there, what was f of, so if f of b, it's the endpoint in f of a. What was f of b in this case? Look up here. See that? That right there is f of b, because in this case, what is b? 4. What's a in this case? 0, and 35 is f of a. So that's where that came from. So here's, hold on a sec. So we know in this case, f of b was what? 21. And what's this one? 35. Now, it's okay that it's negative because error, you can go in either direction, right? How far off are you? It's okay that it's negative, right? And it says if the readings of the rate were obtained every 1/10 of an hour, that's where the 14 comes from, everybody. Do the absolute value of this? You get 14. So if you take it every 1/10 of an hour, what do you do to that 1/10 to get the, what do you do to the 14 with that 1/10? Not divide. It says if the, look, if the readings of the rate were obtained every 1/10 of an hour, by how much would your upper and lower estimates, how much would your upper estimate exceed your lower estimate? How did we get that before? It was 14 times 1/2. So now what is it going to be? 14 times 1/10. So it's going to be 1.4. 1.4. It's getting smaller. Every time, the more readings you take, the error box gets what? Smaller. The more readings you take, the error box gets? The 14 doesn't change, the width changes. So the width is now 1/10. So what happens if it's what? 1 over 100, what is it? 0.14. Look what it says now. It says, how often would you have to take the readings to get the difference between your upper and lower estimate to be 1 liter? So we know that if you took it every 1/10 of an hour, it was 1.4. If you took it every 1/100th of an hour, it would be 0.14, right? What number exists between those two? The number 1. So answer D for me based on the work we just did. Answer D for me. You're going to have to write in 1 over 14. So how often would you need to take this to get a difference between your upper and lower estimate to be 1? It'd be 1 over 14th of an hour. Exactly. Good. Can you divide an hour by 1 over? Sure. Good. Yeah, it's nice.